Hello, I'm Mike Beckett with MD Alignment Services. We're going to make a series of videos on tire wear and handling issues on medium and heavy duty trucks. The information contained in it is going to be basically my opinion and my experience, and the experience of our customers that have fed back to us. You're free to agree or disagree with this as it goes along, but these will be my opinions and we'll list what we think works. I hope you enjoy.
It's about time you showed up.
Well, I was watching the game.
Watching the game.
Chargers.
Gotta like them.
Yeah, I wish I lived in California again. No, I don't.
No, you don't.
No, I don't. Never
you
mind.
don't.
No.
Anyway, I heard about a new problem somebody was having.
A new problem?
Nobody's ever heard of.
Oh, goody. I like a new problem.
This new problem is that the guy says that he's got loose wheel bearings. Well, I say he's got loose wheel bearings because he's got a vibration in the steering wheel and he's got some cupping on the outside edge of his tires.
I thought you said we were going to have a new problem here.
You know, play along.
Play along. Okay. Work with me. Work with me. All right. Loose wheel bearings. The first question comes up is, what is a loose wheel bearing? How do we define it? How do we find it?
Okay.
What is a correctly adjusted bearing? How do we do it? And number three, what would be too tight of a bearing?
True.
Three
What are
concerns.
we trying to accomplish here?
Since we're tire guys, the first thing I'm always looking at is the tire. What is the tire telling me is wrong? And over the years, I've learned that certain types of cupping in a tire tend to be related to wheel bearings.
Okay.
Inside edge on the inside duals tends to relate to wheel bearings. Cupping on the shoulder on steer tires, one edge or the other or both, tend to be caused by wheel bearings. So those are the first things we're looking for. Second, how do we find it? Let's say we jack up a front wheel. Now, a lot of guys will try to jack up the middle of the axle. Now the whole axle teeter-totters back and forth. You can't find anything loose.
Sometimes it's hard.
So we jack up one side and leave one side on the ground solid.
Of an axle, and it doesn't matter if it's a drive axle or a steer axle.
Doesn't matter.
Just jack up the one side.
One side.
If you happen to have one of those hollow tube axles, put the jack under the saddle. Lift that.
It's a preferred way. Right? You can also lift it by the bolts, because you're not going to
Sure.
take anything off.
Sure.
So going on the end of the bolt or the hook bolt's all right with me.
Oh, yeah.
So now we jack it up one side at a time. We have two tapered opposed bearings in that assembly.
Yes, we do.
When you jack the wheel up off the ground, the hub will slide in the valley between those two bearings. And it will feel tight depending on how you wiggle on it.
How you wiggle it.
Wiggle it. Some guys will take a bar and shove it in through the handhole of the tire and try to pry on it to see if it's loose. But what they're doing is they're only moving the hub on one aspect of the bearing. We find we have to wiggle it back and forth in order to get it loose. So a pry bar on a steer axle generally could find a kingpin loose, but it'll tend to miss a wheel bearing.
Misses it. Misses it.
Misses it.
So how do you, let's say you're sticking to the steer. Other than the fact that you've already got cupping wear on the outside.
Which may or may not be caused by the bearing.
May not be caused by it. We are diagnosing this situation. But other than that, how do you find on the steer then this play?
The most effective way I found is to grip the top of the tread of the tire. Physically grip it. Don't just push on the tire. Don't just pull on the tire. Grip it,
Grip it.
and then push and pull back
That
and
outside
forth.
rib. You grip that outside rib.
And just give it a
Push
good
and pull.
hurt.
What if it's so cupped that you don't have an outside rib anymore?
You got a problem.
Got a problem.
Turn it to where you
Long
can get a grip
fingernails.
on it.
Long
Yep.
fingernails. So get them right in there.
Not a
Just
nice
really.
drive nails in, something to hold on to? No, okay. We won't do that either. You
You
got
have to push and pull
Push
at
and
the
pull.
top of the tire.
to wiggle it back and forth up onto the bearing to find the play.
And it will hear what?
Click, click, click.
Click, 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 click.
Bearings
click.
loose.
If you can push and pull, you will hear it.
If you hear clunk, clunk, that tends to be a kingpin.
Well, how will we tell the difference?
The simplest way to tell the difference is to apply the steer axle break.
Step on the brake. Have somebody step on the brake. And
Or
try
make
again.
make a slide tool that fits between the
Slide
brake
tool,
pedal.
sure.
Now you can do it by yourself.
Point being,
If the movement stops when the brake's applied, it's a bearing.
because the bearing, you can't tell that there's any play there as long as the brake is.
Brake's locked up, it's not going to move. If the movement continues, it's a kingpin.
So if you can get the clunk, 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 even though you've got the brakes on, that means the entire spindle
Assembly.
is moving back and forth on
Correct.
the kingpin.
Now, as a general rule, I am much less concerned about kingpin play than wheel bearings.
As a general rule, bearings are very important.
Extremely, because the tire sitting on a bearing is constantly wiggling back and forth, and it's going to give you this perpetual cupping. The kingpin is loose when the weight is on the spindle. That kingpin's kind of locked into place anyway.
Generally.
So I don't get nearly as much cupping out of a kingpin as I do out of a wheel bearing. The other thing is adjusting a wheel bearing is 20 minutes worth of work.
Yeah.
A kingpin is a half a day
And a lot of money.
and a lot of money. So I'm less concerned about that. Now that's how I would diagnose a steer axle. If I go back to a drive or a trailer axle, with two tires, rims, drum, hub, I've got 500 pounds of weight hanging in. When I jack up the one side, that 500 pounds of weight loads down on it.
Sitting down on a much larger bearing now.
And as older as I am, it's getting harder and harder for me to wiggle that and find anything.
Wiggle this drive axle and think you're going to
So what I do is I take a tire iron and I slip the tire iron under the tire and I put a socket down as a fulcrum to use as a lever, and then I can push on the top of the tire iron and I'll find the problem. We'll put a picture in here someplace of that so people know what I'm talking about.
Okay, interesting point there being when you're pushing up and down on the bottom of the tire on the outside,
On the outside rim.
outside of the drive wheel position, you're actually pushing up and out.
Yes, you're levering it because the position of the pressure is so far outboard of the bearing.
You are not lifting it. You are
Right.
pushing it in and out.
Yeah, and you'll find the movement.
That's
You'll
how you
feel it. You'll hear it if that axle shaft is banging against
Clunk,
the side
clunk,
gears.
clunk, 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 clunk.
That's a bearing on a drive axle.
Because there's really nothing else that moves there.
Correct. Shouldn't be anything else that moves it. Okay, so we've been able to diagnose it. We've looked at the tire where we said, oh, it looks like cupping. We jacked it up, and depending on whether I'm a steer axle or a drive axle, I'll use a lever to help me. I find the movement. How much movement is too much movement? Now let's go back and look at what the manufacturers want in end play.
And to play, they want a certain amount.
Correct. The correct way to measure end play in a wheel end is to have the wheels off and the drum off and the end of the spindle opened up and a magnetic base mounted to the spindle and the dial indicator contact against the hub. And then you're supposed to pull the hub straight out and push it straight in so that you're coming up onto the outer bearing and across onto the inner bearing. And that total lateral movement should be between 1 and 5 thousandths of an
1
inch
5 thousandths.
in play. Very, very, very like about the size of a human hair.
Now, just as an addendum on this, how long has that procedure been the one that they have wanted you to use?
Ever since.
Ever since.
It's always
That's
been
always been the way they want
the engineer's final test on a bearing is end play measured with a dial indicator.
Yeah, with an empty hub.
Well, with 500 pounds of weight, there's no way you can find 5 thousandths.
Exactly. So with an empty hub, you got to do this. You get the dial indicator in there, and as long as you can get less than 5 thousandths in play.
Now, if you go back a number of years, back in the 80s,
Quite a number of years.
the spec was 15,000.
15th, yes, and that was fine.
And then it became 10 thousandths, and now for the last 10 years or so, it has been 5 thousandths.
5 thousandths, right?
That's the maximum end play you're supposed to have.
Okay.
You can't feel 5 thousandths end play when you're wiggling a tire.
When you're at the tire, you can't feel it.
You can't feel it at all.
Okay.
It's too small a movement for you to be able to measure
Okay.
and feel. If you're hearing a clicking and a clunking in there, it's more than 5 thousandths.
5 thousandths. You must be more than 5.
Correct. Now, having said that, we understand what the engineers want, and we understand a field method of checking it.
Great field method.
And you can use a dial indicator if you want. The question becomes, what is the proper way to adjust bearings? and what is, in my view, we're back to my view, an acceptable method of adjusting bearings. Understanding that no method is perfect.
True.
Okay? All right. I'm going to describe to you now the method that is recommended by the axle manufacturers and by the Maintenance Council of the American Trucking Association and by everybody who doesn't have to make a living adjusting bearings.
Or doesn't really, their major concern is not getting better tire wear.
No, their major concern is that the bearing doesn't fail.
Exactly.
And they get blamed for it.
Right. They don't want to get blamed.
Okay, and I don't blame them for not wanting to get blamed. That's fine. You've got the bare hub. The bare hub is slipped on. The outer bearing is installed. The adjustment nut is put on. You spin the hub and you torque it to 200 foot-pounds to seat the wheel seal and the bearing components.
Wheel seal, right.
You back it off one turn. You spin the hub, you torque it into 50 foot-pounds. The book says to back it off, depending on the type of hub and axle and stuff, a third of a turn, a quarter of a turn, or a half of a turn. Then you put the washer and the lock nut on.
Or the cotter key, depending on what we've got.
Then you're supposed to put the dial indicator on it, and you're supposed to wiggle it back and forth and make sure you're 1 to 5 thousandths end plate.
Right.
That is the factory procedure. And you can dig out any number of wall charts or manuals, and it will take you through that basic procedure.
That's pretty much it. It's
I mean,
right.
I have no problem with that procedure, except for one small, insignificant problem.
For them, it's insignificant.
If you follow that procedure and you back off a third or a quarter or a half a turn, and you put the cotter key in it or the clip ring in it or you lock it up, you have a 95% chance that when you put the dial indicator on it, it will be more than 5 thousandths end plate. And the reason it will be more has to do with thread pitch.
Thread pitch. Huh.
Now on the end of that spindle where the nut screws on, there are threads, and there's two styles. There's a fine thread, which is 18 threads per inch, or a coarse thread, which is 12 threads per inch.
Well, it's not that much different.
What a 12 thread pitch means is that if you turned the nut 12 times, it would move 1 inch.
So if you turn the nut one time,
you'd move it 83 thousandths.
83 thousandths would be about 1/8 of an inch?
I don't know.
About.
I don't much care.
The point is, it's a lot more than 5.
A lot more than 5 thousandths.
So 1 would be bad. How about 1/2?
Well, let's say you tighten it up to 0.
0. Okay.
And you backed it off 1/4 of a turn.
Of 83 thousandths.
That'd be 21 thousandths.
21 thousandths. How did you just get 21 thousandths with 1/4 turn and end up with 0 to 5 thousandths end plate?
You cannot end up, and 0 is not a good number either, according to the engineers. They want 1 to 5 thousandths.
To 5 thousandths.
There's no way you can wind up with that if you moved it to 21 thousandths.
Well, that's an issue.
Correct. If you had the fine thread, 1 inch is 18 revolutions. 1 full turn is 56 thousandths.
6 thousandths. Okay, so much less than 1.
A quarter of a turn is 14 thousandths.
Still a little high.
3 times what you're supposed to have.
Yeah, you might be able to turn it 1 flat and get almost 5 thousandths end plate. And
might.
let's say, at that point, let's say you're on this bare empty hub, and you've got your dial indicator on it, and you've got 5 thousandths end plate.
Terrific.
Did it.
Got it.
Put the drum on, put the wheel on,
Yes.
bolt it down.
Yes.
Everything's going to be fine now, right?
Should be fine.
If I grab it, chances are I'm only going to have 0 to 5 thousandths end plate.
That's the goal.
That's the goal. Does that happen?
Most times not.
Why not?
One of the other problems that we're finding is that the type of wheel seals that are used today,
Wheel seals.
the seal-in seal like CR or Federal-Mogul,
Sure.
is so stiff
It's stiff. Okay.
that
yeah,
when you've got the weight off and you've only got the leverage you've got on the hub, it feels like you're tight enough.
Yeah.
But when you get the leverage of the wheel on there, you have
wheel
more
and a
movement than you
tire.
thought.
Yeah, but see, now what we're missing here is they didn't care if there was more than 0 to 5 thousandths end play once there was a wheel and a tire on, just when there was an empty
That
hub.
wasn't part of their concern. I
That
agree with
wasn't part of the concern. They didn't care about the tire life.
Now, understanding all of that, you can continue to use factory spec, use a dial indicator, make sure you're 1 to 5. You will follow factory spec. If a problem occurs with your wheel end assembly, you can go back to the factory and complain and see what they'll do for you.
They're not going to do it, because they don't sell tires. They sell
True.
trucks. They sell axles. They sell bearings. But
My problem was that the customers who came to me that wanted me to fix their tire wear problem had to get the bearing adjusted.
Mhm.
So what we did years and years ago, around 1990, is I found an article published in Fleet Owner magazine, written by a guy named Stu Siegel, who's passed on since then. And he was quoting a manufacturer who shall remain nameless. Why should we remain nameless? It's in the article, Federal-Mogul. And the other was two fleets. One was Consolidated Freightways, the other was Victory Express. And they were using torque specs to set bearings.
Torque specs.
Yes. Without backing it off.
No backing off. You just torque it up and you don't back it off.
And you walk away from it.
Walk away.
The concept was that when you're pushing the bearings together with the nut, you're physically lifting and centering a certain amount of weight on the bearing. And it takes so much torque foot-pounds to lift so much pounds of weight.
Right.
Then when you put the second nut on, it jams the inner nut across the thread and picks up a little more torque if you have a double nut. If you have a single nut with a cotter key or clip ring, you don't get that extra.
Right.
As a result of this, they found a certain set of torque specs that worked for them.
Work for them.
I played with it over the years, and I found that if a steer tire is a 11R22.5 or an 11R24.5 or one of their low pros, the weight of the tire, the rim, and the drum and the hub caused me to use a certain torque setting. If I had dual wheels, I have another torque setting. If I have a wide base super single, I have a different torque setting. And if I had an empty hub with no drum, no tires, no rims, I had a different torque setting. Now, I've been using those numbers for about 20 years now, and they work just fine. So, we have a set of specs that we use, and we will show them at the end of this. And you're perfectly welcome to use them any way you want. Or you can continue to use it exactly the way the factory tells you to, using a dial indicator and a bare hub and making sure you're 1 to 5.
There is yet another possibility.
What's that?
You don't have to use our settings, and
No.
you don't have to use that factory setting.
Correct.
You can, on just about every axle available right now, install a retrofitted sleeved assembly.
Yes, there are, since about 2099, a product available from Conmet called a preset, and available from Dana called an LMS.
Yep.
And they are available in kits that you can buy from Timken and SKF and other bearing manufacturers, where you put the bearings in the hub and you put a sleeve on the spindle between the bearings.
You put a sleeve
A
on the
sleeve,
spindle?
yes.
A sleeve?
And when you tighten the adjustment nut down to 250 or 300 foot-pounds,
250 pounds?
and you leave it locked together,
Just leave it there?
and it's all set.
Because the sleeve did what?
Sets the bearing
It
spacing.
set the space between the two bearings so that they roll on the race exactly where they're supposed to be.
And nobody has
Instead
to
of
do that.
instead of adjusting or massaging or doing whatever else,
Just
getting
bing, bing.
monkeys and
And you're done.
killing chickens, whatever you had to do. to
No
try to
burning
fix it.
incense. We're done.
It's a mechanical truth that these two bearings are going to be pushed up against this sleeve, and that's going to be the right distance because that's
all
actually
engineered that way,
with
yeah.
the hub.
I like them. They've been out since '99. Some
A
truck
lot of you guys don't
manufacturers.
even know you have them, and you didn't even know there was such a thing as bearing problems because these things have been out there for 10 years solving your problems.
When one of the truck manufacturers tested it on their steer axle on one of their brands of trucks, they have 2 brands, and the one brand ran it for 2 years, and the other brand did not run it. And at the end of 2 years, they compared their failure warranty complaints between the two. And it was so different that starting in 2002, they became standard on steers and drives on all their highway trucks. And I'm just impressed as heck with them. I like them.
It's been a real game changer.
But if you don't have them, and if installing them is not an option, then you have to know how to properly adjust bearings. Or you're going to have this tire wear issue we talked about.
Or you will have vibrations, or you will have
irregular brake shoe wear,
yes,
intermittent ABS brake light problems,
seal issues.
Seal issues. All of these things.
If the bearings aren't tight enough, you will have those problems.
All of these can propagate from a loose bearing.
One last question.
What?
Lube, grease
versus oil.
Bearings,
does it make any difference to bearing adjustment?
Really? Why not?
Because if you have a heavy grease in there that is a paraffin wax impregnated with a lubricant,
yeah,
the paraffin wax slings itself out and adheres to the surfaces.
Uh-huh.
The oil migrates out of it and still lubricates the bearing the same way. So there's no heavy grease between the bearing and the race.
There isn't heavy grease between. It's been pushed out. How could it stay there unless you packed it so tight that it didn't have anywhere to go?
And it always goes someplace.
Yeah.
So the paraffin wax heats up, moves away, the oil comes in and still lubricates it. So the 1 to 5 thousandths bearing adjustment is no different regardless of the type of lube you use.
Okay. What about the type of bearing? I'm sorry, spindle.
The spindle doesn't bother me.
Spindle doesn't change it.
No.
Barrel type spindle on a trailer
Doesn't
versus
matter.
a spindle, taper type spindle.
Well, the difference between a taper type and a parallel bearing. If you've got a parallel bearing, everything is set this way, so your movement is going to be very free this way. It's not moving up and down the valleys.
Yeah.
But you still don't want any more lateral movement than 5 thousandths.
Yes. Now, the interesting thing that I've found with the barrel type spindle
Parallel
is
bearing.
that it's difficult to find whether it's loose.
Well, with a parallel bearing, you really can't lever it with a bar. You have to push in and out.
Yeah, there has to be, yeah.
Because
now
there is no taper.
And now you got a 500-pound wheel end you're trying to move in and out. So you can't typically find it on your trailer just by looking at it.
It is more difficult, yes.
It's best, if you see the wear on the inside edge, best to just go ahead and make sure those bearings are adjusted.
There are a lot of people who have gotten to that point where they're just tired of messing around with it, and they've played with our torque settings that they like, or they've used a dial indicator, they like it, and they just, to heck with it, I've got a tire wear, I'm going to pull it apart, I'm going to either apply the torque or put the dial indicator, I'm going to make sure it's right.
Just make sure. Because that's what you do about the wear. That's the solution for the wear, is to get to the bearing.
The last thing that you need to remember is that if you tighten up the bearing, you had better reset the sensors on your ABS brakes.
True.
Because the loose bearing is going to cause the sensors to be displaced.
Now, here's what everybody's always concerned about. Here's what everybody is sitting there thinking in the back of their mind. What happens if it's too tight?
If it's too tight, the wheel won't turn.
The wheel won't turn. So this is all, if the wheel spins free,
You're fine.
everything's fine.
If it's not wiggling, and I can still spin it, I'm fine. Now, one other thing on the spin, let's talk about that. I jack up a front wheel and I spin the tire. From experience, a properly adjusted bearing, when you spin it, if you give it a good shot, it's going to turn a turn and a half and it's going to quit. Now, if the bearing is properly adjusted and the bearings are engaged to the race and there's a lubricant on it, it's going to want to slow down.
Eventually.
Typically, if you jack it up and you give it a good shot and it just sits there and spins and spins and spins, usually what that indicates is that the bearings are too far apart, the hub is dropped down, it's only rolling on about the top 3 or 4 rollers, and all of the rest of the race is not engaged, and it'll just sit there and spin.
Interesting.
And when I grab the wheel and shake it, yeah, it's loose. Click, 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 click.
Sure is loose.
Okay? So a slight drag because of the roller engagement and the lubricant is common.
Okay.
Okay?
That works for me.
You have yourselves a great day.
All right.